Subtraction property of equality. If I'm going to solve this equation, I first look for the dangling man. Who's the dangling man? The guy dangling by himself, which would be the 2. So we want to get the x alone. So you think of that as a fence. There's a playground. Here's a yard that they're playing in. Here's a yard. You have an 8 playing in that yard, and you have a 3 in this yard, and an x, and a 2. Well, you want to get the x alone because x's mommy came out of the house and said, X, you can still play in the yard, but your friends have to go home now. So your job is to make his friends go home. Well, his friends are Mr. 3 and Mr. 2. Well, one of his friends is the dangling friend just playing by himself. Maybe on a swing set or something. These 2 are playing together, so you don't want to get rid of the 3 yet. It's easier to get rid of him. How? We do the opposite of what they did. They plus 2, so you're going to do the opposite. Minus 2, minus 2, draw a big line, Now, that's the subtraction property of equality. You can subtract 2 from one side as long as you do it to the other side. Some people call it the golden rule of algebra. The golden rule is do unto others as you would have them do unto you. The golden rule in algebra is do unto the one side as you do unto the other. You can subtract 2 from this side, but you got to subtract 2 from the other side or it's not fair. So minus 2 is the subtraction property of equality. You can still do that and have it maintain its equality. It's still equal because that gives you 6. Bring down your equal. Those disappear because they cancel each other out. You're left with 3x. And then you draw a line, put a 3 over, goodbye, x equal line. And you bottom it to top it and you got it. You bottom it to top it and you got it. What do you get? 2. So the subtraction property of equality says you can subtract whatever you want from this side as long as you subtract it from the other side.